For number 5, a little bit different. Here we're dealing with secant and tangent. So it's not the same as dealing with ones with sine and cosine in them. We have to think about this problem a little bit differently. We have to look at what we know about secant and tangent and how they're related a little bit. So we have secant squared and we have just a regular tangent. What have we learned in the past that kind of relates those two things together? What? Oh, I couldn't hear you. Cosine? Well, secant squared is 1 over cosine squared. Tangent is sine over cosine. So they both have cosine. Alright, so we could actually go ahead and rewrite this in terms of sine and cosine, and we'd end up with sine over cosine cubed. So we could kind of use that same approach that we did on the first page of notes. But there's a little simpler one that we can do if we know some connections here.
I don't know. I think the derivative of secant squared is secant tangent.
Oh, you're on the right track, but not quite the right thing. Melissa? Well, tangent doesn't equal secant squared, but I think you mean derivative of tangent, right? Making up your own rules and stuff. Alright, so derivative of tangent is equal to secant squared, right? So let's think about that in this whole problem that we're doing. We need to figure out a u and a du. What do you think u is going to be, knowing that?
What is UA?
Well, we just said that derivative of tangent is secant squared. So if we set u equal to tangent of 3x, du is going to be the derivative of that, secant squared of 3x. But then we have to multiply the derivative of 3x, which is 3. So we kind of take care of both of these with that u substitution. Now, it's a little different, though, than problems we've done, because generally we're looking for something that's inside of another function. So you might have thought originally, oh, maybe we can make secant of 3x our u, because that's being squared. But that doesn't really work, because tangent is not the derivative of secant. So we wouldn't be able to do that exactly. I mean, we can kind of work around it and do some different things to make that work. But this is probably the easiest way to do this problem. So now, tangent of 3x, that's going to become our u. We have a secant squared of 3x. We've got the dx. We're missing the 3. So if we multiply the inside by 3, outside by 1/3, now we have everything we need for the du part. We have 1/3 times antiderivative of u du. So now that's a real simple integral that we can do the antiderivative of. Add 1 to the exponent, so we get u squared. Divide by 2, or multiply by 1/2, we get 1/6 u squared plus c. So that's 1/6 times tangent squared of 3x plus c. So that's a little bit different than the regular sine and cosine ones. But we have to think about those differently when we have like secant and tangent, cosecant, cotangent. Sometimes you could just like I said, rewrite it in terms of sine and cosine and go that route. Sometimes it'll work, sometimes maybe not. Your answer might look a little bit different, but it can probably be simplified to the same, or rewritten somehow to be the same. For number 6, again, here we've got cosecant and sine. Those two don't really go together as far as derivatives go, right? Derivative cosecant's not sine, derivative sine's not cosecant. But they are kind of connected in another way. How are they related in other stuff you've learned in the past? They're inverses. Well, they're reciprocals, not inverses. Right? They're reciprocals of each other. So we could rewrite this. We can rewrite it a couple ways. So I'm going to write down 2 different versions of this and see if you know which one might be the more helpful version in our case. So cosecant is the same as 1 over sine, right? So if we had 1 over sine times 1 over sine, we get 1 over sine squared. Or we can rewrite the 1 over sine of 2x part. Sorry, this should be 2x. We can rewrite the 1 over sine of 2x part as cosecant of 2x. So really we'd have cosecant squared of 2x. So there's two different ways we could rewrite this problem. Now, for what we're trying to do here, take the antiderivative. What do you think is the better option? I hear a little bit of both. I hear sine, I hear cosecant.
Because cosecant has a positive exponent.
Alright, so I hear cosecant because it has a positive exponent. I hear sine, guessing because people are more comfortable with sine than cosine. Maeve? I know. She didn't want to be on recorded over here. Alright. Well, think about this, guys. What we're going to have to do is take the antiderivative. This would be good over here in terms of sine if we had a cosine in there somewhere. Right? There's no cosine in here. We don't know the antiderivative of 1 over sine squared, if it's written that way. But if we had like a cosine of x up top, cosine of 2x, then we could do what we did on the first page and that worked fine. But it doesn't really work here. The cosecant one is actually going to be the better one, because you guys need to start recognizing these things. This is an antiderivative that you should know. Antiderivative cosecant squared. That's the whole idea with the trig identities, or the trig antiderivatives. We're trying to make them look like one of those 6 trig antiderivatives we did that quick quiz on last week. Antiderivative cosecant squared is negative cotangent. See, people are giving me the wrong answer. That tells me you don't know. And if you knew that, though, you would recognize, oh, that's not so bad. I know the antiderivative of that. The only problem I have to do is take care of this 2x. So that's why I made you guys take that quiz. That's why I told you those are important. You need to know those. So this is our better option here. And all we have to do then is set u equal to 2x. That would mean du is 2 dx. So we need a 2 inside here. We can multiply the inside by 2. Outside by 1/2. So we have 1/2 times the antiderivative of cosecant squared of u du. And like we said, antiderivative of cosecant squared is just negative cotangent of u. So we end up with negative 1/2 cotangent of 2x plus c. And so for the trig antiderivatives, we need to make one of them, unless we can like kind of get rid of the trig parts altogether like we did in some of these, we need to make them look like one of those trig antiderivatives. If you don't know what those trig antiderivatives are, then you're in trouble. You don't know how to get there if you don't know what they are.